Hi everyone. Last class we have seen the working principle of DC motor. Today we are going to see back EMF of DC motors and its significance. So the circuit diagram what you are seeing is nothing but equivalent circuit diagram of DC motors, right? The Vs here, the Vs is nothing but the supply DC voltage, and this EB which you are seeing here, right, this is representation of armature, right? How does the EMF is induced in the DC motors? The EMF is induced in the DC motors when the armature rotates. When the armature rotates, it cuts the flux coming from the pole and EMF is produced in the armature, right? That is, when you supply a voltage to the armature, when you supply voltage to the armature, that armature will conductor will carry the current. While carrying the current, from using the right hand thumb rule, we'll get the force applied on the armature. That twisting force will leads to the rotation of armature, right? Understood? I repeat, when the armature rotates, it cuts the flux coming from the pole and EMF is induced in the armature by Faraday's first law. What does the Faraday's first law states? The Faraday's first law states the induced EMF is directly proportional to the rate of change of flux. That is indicated as E is directly proportional to d phi by dt. This EMF is called back EMF. Why it is called back EMF? It is called back EMF because it opposes the applied voltage. That is, it is opposing the applied voltage Vs. Because of Vs supply voltage to the armature conductor, the armature conductor cuts the flux and the EMF induced. But the whatever the induced EMF we get, it opposes the supply voltage, hence we call it as back EMF. This opposition of supply voltage, like the EMF opposing the source which is causing for it, is nothing but Lenz's law. The back EMF will have same formula as induced voltage. The induced voltage what we derived in DC generator is nothing but E is equals to P phi NZ by 60A, right? Where phi is the flux, where P is the number of poles, N is the rotation of armature in RPM, Z is the number of conductors, and A is nothing but the parallel path. Understood? Later, coming to the equivalent circuit diagram of DC motors, by using KVL, we get it a equation Vs is equals to Ia Ra plus Eb plus V brush drop. The brush drop is nothing but the drop the resistance of the brush which is connected to the commutator. So every brush has a drop. Whenever in the problems, when the V brush is not given, we are going to neglect it. Now let's see what is the significance of back EMF. Using the KVL, we got the equation. We rearrange the equation in this form. That is, I is equals to V minus EB divided by RA, where N is nothing but the speed of rotor, that is given in RPM, where Ia is nothing but armature current, that is in amperes. Okay, let us see what is the significance of back EMF. The main purpose of back EMF is nothing but the back EMF makes the motor self-regulating. What do you mean by self-regulating? That is, when you load means you want to do a more work, or you want more work from a motor, you're going to load, right? The task which is given for the motor to function will be high, then it is called as loaded. When you loaded, what happens? The armature conductor speed decreases. That is, when you loaded, NR decreases. Okay, so what happens? Cutting of armature conductor with magnetic flux decreases. Understood? When you load, the armature conductor rotations speed decreases. Due to this, the armature conductor cutting of armature conductor with magnetic flux decreases. When you decrease that, what happens? That is NR. As the load increases, rotor speed decreases. When the rotor speed decreases, the induced EMF decreases. Right? Understood? When the armature conductor cuts the flux, the EMF is induced, that we have seen in last class itself. When getting this, knowing about this and substituting in this equation, when EB decreases, which is minus EB, when the value of minus EB decreases, what happens? The armature current increases. I repeat, when minus EB, that is induced EMF, decreases, which is of minus C, from this equation we can come to know that as EB, induced EMF, decreases, the armature current increases. Hence, what happens? The NR, the rotation of armature speed, comes to the original value. One, it has decreased because of load, but it has increased because of armature current. Hence, the armature speed comes to the original value, which makes the motor self-regulating. Right? Understood? When you remove the load, what happens? When you are free, we have removed the load, the speed of the armature, right? The speed of the armature increases. When the speed of armature increases, the induced EMF also increases. That is nothing but the cutting of armature conductor with magnetic flux increases. Due to this, the induced EMF increases. By knowing this equation, let us put it together. When the induced EMF increases, which is of minus, right? Whenever it is a minus, what happens? This value increases. When the induced EMF increases, the armature current decreases. Due to this, what happens? The NR value comes to the original value. So, speed of the armature is reduced to its original value, from high to original value. Here, in this condition, from low to original value. Understood? Thus, by this, back EMF makes the motor self-regulating. I hope you understood this concept. Please see the video once more. If you have any doubts, please comment below. Thank you.